Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dokwa Jr., your math tutor. I am an instructor of mathematics at the University of Liberia. In today's lesson, we want to look at the nth derivative. So in previous lesson, we started with higher order derivatives. That is the first order, the second order, the third order. Now let's see how we can find some n order. Assume you want to find the 19th order or the 19th derivative of a function. You want to find the 100th derivative of a function, the 900th derivative of a function. How do we go about finding the nth derivative? So we have the first full set of examples. So the first example says y equals to pi x cubed minus 7x. Now we find the first derivative. So in order to find the nth derivative, we first find the first few set of derivatives, at least the first 3 sets of derivatives, so that we observe the pattern and formulate a formula that can be used to find the nth derivative or just any other derivative of that particular function. So we find the first derivative, y prime. Now consider that this pi is a constant. So you have pi x cubed minus 7x. So it's 3 times pi, which is 3 pi. X, we subtract 1 from this 3, is 2. Minus, the power is 1. 7 times 1 is 7. Subtract 1 from this is 0. X to the 0 power is just 1. So we found the first derivative. Now we move to the second derivative. 2 times 3 is 6. 6 pi x to the first power, because you subtract 1 from this, and the derivative of this constant goes to 0. Now let's find the third derivative. So 1 times 6 is now 6 times pi. Subtract 1 from there is x to the 0 power. X to the 0 power is just 1. And let's find the nth derivative. So please put this in parentheses, because we told you in our previous lesson that whenever you want to write the fourth derivative, the fifth derivative, you always have them in parentheses. This is not equal to y raised to the fifth power. This is the fifth derivative of y. This is y raised to the fifth power. So for this now, the nth derivative. Now this is a constant. So when you are differentiating any other, you are finding any other derivative of this function further, right? It will be equal to 0. So when is it equal to 0? This is equal to 0. The derivative equals to 0 when n is equal to 4 or n is greater than 4. So we can just rewrite it as n is greater than or equal to 4. Similarly, if you had y equals to 2x and you want to find the nth derivative, so you found the first one, y prime equals to 2, y prime prime, right? It's equal to 0, right? Y to the nth is also 0. When is this? When actually did we experience 0? So we can say n is greater than or equal to 2. So when n is greater than or equal to 2, when n is equal to 2, the derivative is just equal to 0. So you don't have to go further, because you know that beyond the second derivative, every other derivative is just equal to 0. Okay. So let's do the second problem. The second problem is similar to these two problems we just went away. So question 2 says y equals to 3x cubed plus 5x squared plus 4x plus 1. So again, we can find the first set of derivatives, at least 3 of them. So we say y prime equals 3 times 3 is 9. X, we subtract 1 is 2. 2 times 5 is 10x, and then plus 4. We find the second derivative. 9 times 2 is 18x plus 10. We find the third derivative. This is just 18, and then this is 0. So the fourth derivative, let's say the nth derivative now, would just be equal to 0. At n is greater than or equals to 4. So when n is equal to 4, or n is greater than 4, we will have our derivative to just be equal to 0. Okay, so let's look at the third problem. So the third problem says y equals to 1 over x. So we find the first derivative. So the first derivative, y prime, we use the quotient rule, or we can send this x in the numerator and we can use the product rule. So we can say, let's say the power rule. So we send this one in the numerator, we have x to the power minus 1. So y prime, sorry, this is just, so y prime now becomes, we bring this 1 minus 1 down, we rewrite x, and we subtract 1 from this, it gives us minus 2. We find the second derivative, bring this 1 down, so it's minus 1. So minus times minus is positive, so this positive go out. This is 2, x raised to the power, subtract 1. Let's say we subtract 1 from here, now it's minus 3. So y prime prime prime, bring this 3 down, so it now becomes negative. Negative 1 times 2 times 3, x raised to the power minus 4. So if we move to the next derivative, the fifth one, and the sixth, we are observing a particular pattern. So it is from that pattern now we want to write a formula for the nth derivative of this particular problem. So whenever you have y equals to 1 over x, and then you were asked to just find the 13th derivative, the 30th derivative, you can just use that formula directly. So what will be the nth derivative? Now, what are the patterns that we are observing? The first thing, we observe that there's a negative sign, there's a positive, there's a negative, and so forth. So it means that the signs will alternate. That is negative, positive, in the order of negative first, positive second, negative first, and so forth. So when negative is first, you just raise it to the highest derivative. So when n is equals to 1, if you are finding the first derivative, minus 1 raised to the first power, you will just have minus 1. If this was to start with a positive and continues with a negative and positive and so forth, you would have added 1, n plus 1. Or you can also say n minus 1. It's still the same, nothing changed. Minus 1 raised to the power n minus 1 or n plus 1. So when n now is equal to 1, what will you get? You get 1 plus 1 will give you what? We just give you 2. So when the power is even, what you will get here will be positive. So when this is also 1, 1 minus 1 is 0. So minus 1 raised to the power 0 is also equal to positive 1. Because whatever expression raised to the power 0 is just equal to positive 1. So notice that when it begins with a negative, you just say minus 1 raised to the highest derivative n. That's the first pattern. Another pattern is we see that the first derivative we have 1. The second derivative, we have 1 times 2. The third derivative, we have 1 times 2 times 3. And we know that 2 factorial, for example, is equal to 2 times 1. 3 factorial is equal to 3 times 2 times 1. 4 factorial is equal to 4 times 3 times 2 times 1. So we observe that this is in a pattern of a factorial. So this is 1 factorial, this is 2 factorial, this is 3 factorial. So dot dot dot, what will we have? We have the n factorial, because you want to find the nth expression. So if you are finding the 10th derivative, 10 factorial minus 1 raised to the 10th power, y raised to the power, open parenthesis, you have your 10 right here. Then what's about this? This is the last one. So we observe that the first derivative we had, what did we have? The first derivative. We subtracted 1, right? From this, we got 2. Okay. So the first derivative, we got 2. So understand, just notice something. When this is 1, this is 2. When this is 2, this is 3. When the highest value here is 3, this is 4. So this is increasing by 1. So if you are considering this pattern to be n factorial, where n represents the highest value, it means that we should just say minus, because this minus is constant, right? And then we just add 1. So it's just to say n plus 1. Then we are done. But because this is negative, we can rewrite that as minus 1 raised to the nth power times n factorial, all over x raised to the power n plus 1. So let's test it and see. So this now becomes the n. This is the formula for finding the nth derivative of a particular, of this particular function. Let's see. Now we found these derivatives already, the first, the second, the third. So we can, in order to verify, we can use these same derivatives. So let's say we want to find the second derivative. Using this formula, find the second derivative. So y raised to the power, so n now is equals to 2, right? So we don't write 2 like this. No. The traditional way of writing second derivative is using the double stroke. The third derivative using 3 strokes. When it is beyond third derivative, you can use this parenthesis. So we just have prime equals minus 1 raised to the power 2. Now for this, we have to use a 2. This is 2 factorial all over this x raised to the power 2 plus 1. So negative 1 raised to the second power means positive, right? So 2 factorial means 2 times 1, which is 2. Or we say 2 times 1, whatever the case might be. And then down here you have x raised to the power 3. What was it? This is second derivative. If you send this expression in the denominator, you have 1 times 2 x raised to the power positive 3. This is exactly what you get. This 1 times 2 is the same as 2 times 1, or just equals to 2. If we want to find the third derivative, and we're going to get the same thing. So let's include something different. What if we want to find the 20th derivative? The 20th derivative. So you know that if you want to find the 20th derivative of this, and you think that you want to manually do it like this, it's going to waste your time. That's going to be a lot of work. So you just derive a formula and use a formula now to find whatever derivative you want to find. If we want to find the 10,000 derivative right now, we can just use the formula and find it. So let's say we want to find the 20th derivative. So we say minus 1 raised to the power 20 times 20 factorial, all over x raised to the power 20 plus 1. So this will give us, now, minus 1 raised to the 20th power. When the power is even, this becomes positive. When the power is odd, this becomes negative. So the power is even. So this is just 20 factorial all over x raised to the power 21. So we can expand this 20 by saying 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you can just do the multiplication for that. So it's like 20 times 19 times 18 times 17 all the way to 1. You just do the multiplication, you get the value for 20 factorial. Okay, so let's look at the last problem. So the last problem says y equals to 1 all over 3 plus x. So again, we can decide to just send this term across, let's say within the numerator. So this would now give us y equals 3 plus x raised to the power minus 1. Then we find few derivatives. So we say the first derivative, bring this power down, is minus 1, 3 plus x. Subtract 1 from this power, it gives us minus 2. Find the second derivative. So negative and negative is positive. So this gives us 1 times 2, 3 plus x raised to the power. Now, you subtract 1 from this, it gives you minus 3. Right? And then the rule says we must differentiate inside, isn't it? So okay, now, so the first time was this, and then we got this. So now we want to differentiate this. So we brought this power down, we got this, right? Okay, let's continue. So if you differentiate in here, the derivative of 3 is 0, the derivative of x is 1. So it doesn't really, it's not really important. So let's find the third derivative. Bring this power down again, so you have 1 times, so it becomes negative now. So it's negative 1 times 2 times 3. Now I'm not multiplying it so that I can observe the pattern of the numbers. So this gives us 3 plus x raised to the power minus, so we subtract 1 from here, it's minus 4. So we continue. Let's see if we're to find the fourth derivative. You will have positive because negative times negative is positive. 1 times 2 times 3 times 4. 3 plus x raised to the power minus 5. So you see that? It's just continuing. So if we look here, if we carefully rewrite this, we can have negative 1 all over 3 plus x raised to the power positive 2. This one will be positive 1 times 2, right? So it's 1 times 2 all over 3 plus x raised to the power positive, what is it? It's positive 3. Because we reciprocate and then the power changed to positive instead of negative. So this now gives us minus 1 times 2 times 3 all over 3 plus x raised to the power positive 4. And then this one gives us 1 times 2 times 3 times 4 all over 3 plus 4 raised to the power 5. So we can observe the pattern. So we say dot dot dot. The nth derivative for this would just be, now because the sign is also alternating, it begins with a negative, we can have minus 1 raised to the power n. Also, we see that 1 times 2 times 3 times 4, we can say n factorial. And then down here now we have 3 plus 4. Now this is 5 and this is 4. So it means you just add 1 to it. So there's a formula for this particular function, the nth derivative formula for this particular function. So what if we want to find maybe the third derivative? Let's say the third derivative. So we have y dot dot dot. This is the third derivative. Minus 1 raised to the n. So it's minus 1 raised to the third power 3 factorial all over 3 plus. Now this is not 4. This is x. Okay. So this is 3 plus x raised to the power 3 plus 1. So y prime 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 equals, now when the power is odd, it ends in negative. 3 factorial is like 3 times 2 times 1. So it's just 3 times 2 times 1 all over 3 plus x raised to the power 4. And what was it? The third derivative, this was it. Negative 1 times 2 times 3 divided by 3 plus x raised to the 4th power. This was it. So this is how we find the formula for the nth derivative of functions. So in our next lesson, we will also find the formula for the nth derivative of some trigonometric functions and other higher functions. So thanks ever so much for watching. Please don't forget to subscribe and you share the video, because one of the ways that I'm motivated is because of the number of viewers and number of subscribers and everything that I do have. With outside of that, I might not really have that zeal to do more and more in these different courses. These are time consuming. You have to put notes together and everything before you come up to make a video. So please subscribe, like, and share. Thank you very much, and see you in our next lesson.